Long before humanity understood gravity, before telescopes stretched their mechanical eyes toward the heavens, before scientists gave names to craters and Maria, there was simply a glow in the darkness, a quiet companion rising faithfully into the night sky. The moon has always felt less like an object and more like a presence. When the world grows quiet and the noise of the day dissolves into the soft hum of crickets and distant wind, that pale silver light spills gently across rooftops, oceans, deserts, and forests, asking for nothing, demanding no attention, and yet holding it completely. It is the most familiar object in our night sky, and yet it remains deeply mysterious. You have seen it thousands of times, perhaps without noticing how it changes, how it breathes in phases, how it slowly shifts position night after night. There is something ancient about that rhythm. The moon is not simply orbiting Earth, it is dancing with it, locked in an elegant gravitational embrace that has lasted for over 4 billion years. Imagine that span of time for a moment, longer than mountains have stood, longer than oceans have held their shape. During that vast stretch, the moon has been slowly drifting away from us, about the width of your fingernail each year, silently increasing the distance between itself and the planet it orbits. And yet it never leaves. It remains tethered by gravity, the invisible thread that shapes the architecture of the cosmos. The light we see is not its own, but sunlight reflected off ancient rock and dust, traveling across space in just over a second before touching your eyes. That glow left the sun 8 minutes earlier, bounced off the moon's surface, and completed its journey upon your retina, a chain of light connecting star, satellite, and human in a single quiet instant. When you look at the moon, you are seeing sunlight that has taken a delicate detour through space. The darker patches that form the familiar face are vast plains of cooled lava, formed billions of years ago when asteroids struck and cracked the young lunar crust, allowing molten rock to flood outward and freeze into smooth basalt seas. They are called Maria, Latin for seas, named by early astronomers who believed they were filled with water. There is no liquid water there now, only dust so fine it clings like powdered ash. And yet the moon influences the water here on Earth every single day. Its gravity pulls gently at our oceans, lifting them into tides that rise and fall with predictable patience. Without the moon, our planet would be profoundly different. Our days would be shorter, our climate more chaotic, our seasons less stable. Some scientists believe the steady presence of the moon helped Earth maintain the gentle axial tilt that allowed life to flourish. So when you see that soft disk in the sky, you are not just looking at a decoration of the night. You are witnessing a stabilizing force that may have helped make your own existence possible. The moon is tidally locked to Earth, which means it rotates at exactly the same rate that it orbits us. That is why we only ever see one face. The far side remained hidden from human eyes until spacecraft circled behind it in the 20th century, revealing a landscape more rugged and heavily cratered than the side we know. For billions of years, that hidden hemisphere existed unseen, a reminder that even the most familiar celestial body still keeps secrets. When astronauts from NASA traveled there during the era of the Apollo program, they described the silence as absolute, a silence so complete it felt almost physical. No wind, no atmosphere, no sound. Just the faint vibration of machinery and the slow beat of a human heart inside a pressurized suit. The moon's gravity is only 1/6 of Earth's, allowing astronauts to move in slow, floating arcs, each step a gentle bound. But even before humans set foot upon it, the moon had already shaped mythology, navigation, agriculture, and poetry across countless civilizations. It marked time long before clocks existed. Its phases created the foundation of early calendars. It served as a compass in the night for travelers crossing oceans and deserts. There is comfort in its predictability. Every 29.5 days, it completes its cycle from new to full and back again, a steady reminder that change itself can be rhythmic and calm. If you were to stand on the moon and look back at Earth, you would see a blue and white marble suspended in blackness, rising and setting in the lunar sky. From that perspective, our planet becomes the luminous object, and the moon becomes the ground beneath your feet. The roles reverse, but the connection remains. In the quiet glow above us, there is a story of gravity, light, time, and companionship. And as we begin this journey into sleepy science facts about moons, remember that what seems simple and familiar is often the doorway to something vast, ancient, and beautifully complex. If you travel back in imagination to the earliest days of our solar system, the scene is far from peaceful. There are no gentle tides yet, no stable orbits tracing smooth ellipses. Instead, space is filled with swirling debris, fragments of rock and metal colliding in a chaotic ballet around a young, bright Sunday. Planets are still forming, growing larger with each impact, their surfaces molten and glowing. In that violent beginning, moons are not carefully crafted objects placed delicately into orbit. They are born from catastrophe. The leading scientific theory for the origin of our moon is called the giant impact hypothesis. And though the name sounds dramatic, the reality was even more extraordinary. Roughly 4.5 billion years ago, a Mars-sized protoplanet, often referred to as Theia, is believed to have collided with the young Earth. The impact was not a simple crash but a glancing blow, powerful enough to vaporize rock and send enormous amounts of material spiraling into space. For a time, Earth was encircled by a glowing ring of debris, like a temporary second set of rings similar in appearance to those we admire around Saturn. That debris slowly began to clump together under its own gravity. Small fragments merged into larger bodies, and larger bodies merged again, until eventually one dominant sphere emerged, clearing its orbital path and becoming our moon. It formed quickly in cosmic terms, perhaps within a few hundred years, an infant satellite glowing with heat from its violent birth. Its surface was likely covered in a global ocean of magma, gradually cooling and solidifying over millions of years. This is the quiet paradox of moons. They are often born in fire and collision, yet they spend the rest of their existence in silent orbit. Not all moons share the same origin story. Some are formed through capture, when a planet's gravity snares a wandering asteroid and pulls it into orbit. This is thought to be the case for some of the irregular moons orbiting the giant planets. Others form alongside their planets from the same disk of material, coalescing together like siblings growing in the same cosmic nursery. The diversity of moons across our solar system is astonishing. Jupiter alone hosts dozens, including the 4 large Galilean moons first observed by Galileo Galilei in 1610, forever changing humanity's understanding of the universe. Those observations provided evidence that not everything orbited Earth, a revelation that shifted our cosmic perspective forever. Among those moons, Europa hides a global ocean beneath its icy crust, warmed by tidal forces generated by Jupiter's immense gravity. Io is the most volcanically active body in the solar system, its surface constantly reshaped by eruptions fueled by gravitational squeezing. Ganymede is larger than the planet Mercury and possesses its own magnetic field. Each moon tells a different story of formation, environment, and possibility. Some moons are small and irregular, shaped like lumpy potatoes rather than perfect spheres. Others are massive and complex, rivaling planets in size and intrigue. Beyond our solar system, astronomers now search for exomoons orbiting distant exoplanets, hoping to detect the faint dimming of starlight that might reveal their presence. It is possible that some of those distant moons could host atmospheres, oceans, or even conditions suitable for life. The birth of a moon is an act of gravity gathering fragments into unity. It is the transformation of chaos into orbit, of scattered debris into companionship. And once formed, a moon begins its long, steady journey around its parent planet, influencing tides, stabilizing tilts, shaping climates, and reflecting sunlight across darkness. When you gaze up at our moon tonight, remember that its serene glow began with unimaginable violence. Its calm face hides a history written in impact scars and molten seas. And yet from that turbulence emerged a presence that has watched over Earth for billions of years. In the vast architecture of the cosmos, moons are not rare decorations. They are dynamic participants in planetary systems, silent architects of stability and change. Their origins may be explosive, but their existence becomes rhythmic, dependable, almost meditative. And as we continue drifting deeper into the science of moons, you may begin to feel that each one, no matter how distant, carries its own quiet story, circling patiently in the dark. There is something deeply soothing about watching the moon change, not suddenly, not dramatically, but slowly and with quiet patience, as if it were breathing in light and exhaling shadow across the velvet sky. Night after night, it reshapes itself, sometimes appearing as the thinnest silver thread resting delicately above the horizon, other times swelling into a radiant, luminous circle that commands the darkness without ever disturbing its calm. This transformation is not magic, though it can feel like it. It is geometry, sunlight, motion, and timing woven together in a cosmic rhythm so steady that it has guided human calendars for thousands of years. The phases of the moon occur because of its position relative to Earth and the Sun, and as it orbits our planet over approximately 29.5 days, different portions of its sunlit half become visible to us. When the moon sits between Earth and the Sun, its illuminated side faces away from us, and we experience the quiet invisibility of a new moon, a night when the stars seem sharper and deeper because the lunar glow has stepped aside. Gradually, a thin crescent emerges, like a whispered promise returning to the sky, growing each evening as more sunlight reflects toward us. This waxing phase continues until the moon reaches its first quarter, half illuminated, half in shadow, a perfect balance that feels symbolic even though it is purely orbital mechanics at work. And still it grows, swelling into a gibbous shape before finally reaching the full moon, when Earth sits between the moon and the sun, and the entire face shines brilliantly, flooding landscapes with pale silver light that softens edges and transforms familiar places into something dreamlike and hushed. Yet even at its fullest, the moon is not changing shape at all. It is always round, always whole. What shifts is our perspective, the angle from which sunlight greets its surface and returns to us. There is comfort in that truth, the idea that something can appear to diminish and grow while remaining complete all along. As the days pass beyond the full moon, the cycle reverses. The light slowly recedes, the moon wanes, returning through gibbous and quarter phases until it becomes a delicate crescent once more, and finally slips back into darkness, completing its orbit and beginning again. This cycle has repeated for billions of years, long before the first human gaze lifted upward in wonder. Ancient civilizations built myths around these changing faces, seeing gods, animals, or spirits in the shifting patterns of light and shadow. Farmers planted crops according to lunar phases, sailors navigated by its glow, poets found metaphors in its constancy and change. Even now, despite our satellites and digital clocks, many people still feel subtly aware of the full moon's arrival, as if some quiet instinct recognizes the brightness in the night. The surface features that create those shifting patterns are ancient scars and plains, formed by impacts and volcanic flows during the moon's turbulent youth. The darker regions, the Maria, are immense basalt plains created when asteroid collisions fractured the crust and allowed molten rock to flood outward and cool. The lighter highlands are older, heavily cratered, and reflective, giving the moon its mottled appearance. When sunlight strikes these different terrains at varying angles, the shadows lengthen or shrink, revealing ridges and crater rims in dramatic contrast during the quarter phases, while the full moon flattens detail under direct illumination. If you have ever noticed that the moon appears larger near the horizon, that too is an illusion of perception rather than physics, known as the moon illusion, where our brains compare it to trees, buildings, and distant landscapes, making it seem grander than when it hangs high and isolated in open sky. Through telescopes, the moon reveals even more faces, crater walls rising like frozen waves, central peaks standing within circular basins, vast impact structures stretching hundreds of kilometers wide. During the era of the Apollo 11 mission led by Neil Armstrong, humanity saw yet another face of the moon, not as a distant symbol but as solid ground beneath human boots, powdery regolith compressing softly under careful steps. The photographs returned to Earth showed a stark and beautiful world, gray and silent, horizons curved sharply against black sky. Yet even those images captured only one hemisphere, the side eternally turned toward us due to tidal locking. The moon rotates on its axis in exactly the same time it takes to orbit Earth, about 27 days, creating the illusion that it does not spin at all. In truth, it does rotate, but in perfect synchrony, always presenting the same face like a faithful companion maintaining eye contact. There is something profoundly intimate about that arrangement. Two celestial bodies locked in gravitational partnership, moving together through space while one side remains hidden, unseen from Earth without the aid of spacecraft. And still, with all our measurements and missions, the moon retains its quiet mystery. It influences tides, subtly lengthens Earth's day as it drifts slowly outward, stabilizes our planet's axial tilt, and reflects sunlight that began its journey at the core of the sun millions of years ago. When you lie beneath a full moon and feel its cool glow resting on your skin, you are participating in a chain of cosmic motion and reflection that began long before humanity and will continue long after. The many faces of the moon are not separate personalities but phases of illumination, gentle reminders that change can be cyclical and predictable, that darkness and brightness take turns without conflict. In its slow orbit and patient rhythm, the moon offers a lesson written in light and shadow, a story of motion so graceful that it feels almost like breathing, steady and eternal above the sleeping world. For most of human history, the moon seemed fully known, its familiar face mapped in imagination long before it was mapped in ink. People traced shapes in the dark Maria, saw faces and animals in the patterns of light and shadow, and believed that what they saw was the moon in its entirety. It hung there faithfully, showing the same markings night after night, century after century, as if it had nothing more to reveal. And yet, quietly and without announcement, half of the moon remained forever turned away from Earth, hidden not by distance but by the simple elegance of orbital mechanics. The moon is tidally locked, which means its rotation period matches its orbital period around Earth. It takes about 27 days to spin once on its axis and the same amount of time to complete one orbit around our planet. Because of this perfect synchronization, we only ever see one hemisphere from Earth. The other half, often mistakenly called the dark side, is not permanently dark at all. It receives just as much sunlight as the near side, experiencing its own long days and long nights. It is more accurately called the far side, a hemisphere that remained unseen by human eyes for billions of years. Imagine that mystery for a moment. For all of recorded history, every story, every poem, every scientific sketch was based on only half of the moon's surface. The far side existed in silence, turning patiently through space, illuminated by sunlight but invisible to the civilization that gazed upward in wonder. It was not until 1959 that humanity finally glimpsed this hidden hemisphere, when the Soviet spacecraft Luna 3 flew around the moon and captured the first grainy photographs. The images were blurry and imperfect, yet they revealed something astonishing. The far side looked dramatically different from the familiar face we knew. Instead of large, dark Maria spread across smooth plains, it was dominated by rugged highlands and a dense scattering of impact craters. It appeared more ancient, more scarred, almost wilder in character. This difference puzzled scientists. Why would one side of the moon have vast basalt plains formed by ancient volcanic activity, while the other side remained heavily cratered and comparatively lacking in Maria? The answer may lie deep within the moon's early history. The crust on the near side is thinner than on the far side, which may have allowed molten lava to break through more easily after massive asteroid impacts. On the far side, the thicker crust may have prevented lava from flooding the surface in the same way. Over billions of years, this geological asymmetry created two distinct hemispheres, like twin siblings shaped by slightly different experiences. There is something quietly poetic about this imbalance. The side we see is smoother, marked by dark plains that ancient astronomers once mistook for seas. The hidden side is more rugged and heavily cratered, preserving a record of impacts from the early solar system. It is as though the moon presents its calmer expression toward Earth while keeping its more chaotic history turned away. Yet this is not intentional, not emotional. It is simply the outcome of gravity, heat, and time. Still, the symbolism lingers when we think about it. Even a celestial body can have a hidden half, unseen yet equally real. When astronauts orbited the moon during the Apollo program, they became the first humans to witness the far side directly with their own eyes. As their spacecraft passed behind the moon, radio communication with Earth was temporarily lost. For those moments, they were completely cut off from the planet, shielded by the lunar bulk. The silence was profound. On the far side, there is no direct radio interference from Earth, making it one of the quietest radio environments in the inner solar system. Scientists have proposed that one day, radio telescopes could be placed there to study the faint signals of the early universe, protected from the noise of human technology. One of the most striking features on the far side is the South Pole Aitken Basin, one of the largest and oldest impact structures in the entire solar system. Stretching roughly 2,500 kilometers across, it is a colossal scar left by an ancient collision. Standing on its rim, if it were possible without a spacesuit and careful engineering, you would see a horizon shaped by a catastrophe that occurred billions of years ago. That impact may have excavated material from deep within the moon's interior, offering scientists clues about its composition and formation. In this way, the far side is not merely hidden terrain, it is a geological archive. In recent years, robotic missions have returned to explore this once invisible hemisphere. In 2019, China's Chang'e 4 successfully landed on the far side, marking the first soft landing there. The mission transmitted images of a stark landscape, illuminated by sunlight filtering across a crater floor, the sky above utterly black. These photographs carried a quiet significance. What had once been unreachable and unseen was now part of human exploration, expanding our sense of familiarity with the moon. And yet, despite spacecraft and high-resolution maps, the far side retains its mystique. Perhaps it is because we cannot see it with our own eyes from Earth. We must rely on images, data, and imagination. When you look up at the moon tonight, remember that behind that glowing disk lies an entire hemisphere turning silently through space, its craters and highlands bathed in sunlight you cannot witness. It is there, steady and patient, completing each rotation in perfect synchrony with its orbit, never revealing more than one face at a time. There is comfort in that hiddenness. The moon does not rush to expose all of itself. It moves with quiet consistency, holding half its story just out of sight. In a universe filled with violent explosions and unimaginable distances, this gentle mystery feels almost intimate. The far side reminds us that even the most familiar presence in our sky still carries secrets, turning slowly in the darkness, illuminated by the same sunlight that eventually finds its way to Earth. And as we continue drifting deeper into the science of moons, we carry with us that awareness, that beyond every visible face lies another, waiting patiently in silence. If you could stand quietly on the moon's surface, beneath a sky so black it seems almost infinite, you would find yourself surrounded by a landscape shaped not by wind or water, but by impact and time. There would be no rustling leaves, no shifting clouds, no distant ocean tides. The silence would be complete, interrupted only by the faint vibration of your own movement through the regolith beneath your boots. And as your eyes adjusted to the sharp contrast of sunlight and shadow, you would begin to notice that the moon's surface is not smooth at all, but sculpted with extraordinary detail, as if carved by invisible hands over billions of years. The most striking features are the craters, circular depressions scattered across nearly every visible stretch of terrain. Some are small, barely wider than a house, while others span hundreds of kilometers, vast enough to swallow entire mountain ranges on Earth. These craters were formed when asteroids and comets, traveling at tremendous speeds, collided with the lunar surface. Without a thick atmosphere to burn them up before impact, even small fragments of rock could strike the moon directly, releasing explosive energy that blasted material outward in all directions. The result was a bowl-shaped cavity surrounded by a raised rim, often with a central peak formed by the rebound of compressed rock. Over time, newer impacts layered atop older ones, creating a complex record of collisions that stretches back to the early days of the solar system. On Earth, craters are gradually erased by erosion. Wind softens their edges, water fills them, tectonic activity reshapes the land. But the moon has no atmosphere, no flowing rivers, no shifting plates. Its scars remain preserved, sharp and ancient. Some of the largest basins, like the immense Imbrium Basin, were formed by impacts so powerful they fractured the crust itself. In the aftermath of those colossal collisions, molten rock welled up from below, spreading across the basin floor before cooling into smooth, dark plains. These plains are what early astronomers mistook for seas, giving them names like Mare Tranquillitatis and Mare Serenitatis. Though they are not seas of water, their smooth appearance contrasts beautifully with the brighter, heavily cratered highlands that surround them. The Moon's mountains are equally dramatic. Along the edges of large impact basins rise towering ranges, some peaks reaching heights comparable to the tallest mountains on Earth. The Montes Apenninus, for example, curve gracefully along the southeastern rim of the Imbrium Basin, casting long shadows when the sun hangs low on the lunar horizon. Unlike Earth's mountains, which are often formed by tectonic forces pushing plates together, many lunar mountains are uplifted rims of impact craters or blocks of crust displaced by ancient collisions. They are monuments to moments of sudden violence, frozen in place under an eternal sky. The lunar surface is covered by regolith, a fine, powdery layer of crushed rock and dust created by billions of years of micrometeorite impacts. Each tiny collision pulverizes surface material, gradually grinding solid rock into grains as soft as ash. When astronauts from NASA walked on the Moon during the Apollo 15 mission, they described how the regolith clung stubbornly to their suits, its particles sharp and angular due to the absence of weathering. In photographs, their footprints remain crisp and undisturbed, preserved in a place where no wind will ever erase them. Those impressions may last for millions of years, quiet signatures of human presence on a world otherwise shaped only by cosmic forces. Perhaps the most calming thought is that the Moon's landscape changes very slowly now. The heavy bombardment period that once reshaped its surface has largely passed. Today, impacts still occur, but far less frequently. Occasionally, astronomers on Earth observe brief flashes of light on the lunar surface, evidence of small meteoroids striking the ground. Yet these events are minor compared to the colossal impacts of the past. The Moon rests in a quieter era, its dramatic features already formed, its great basins and craters settled into stillness. If you were to watch a lunar sunrise from the edge of a crater, you would see shadows retreat slowly across jagged terrain as the sun rises over the horizon. Because a lunar day lasts about 29 Earth days, the sunlight moves with extraordinary patience. Shadows stretch long and sharp, emphasizing every ridge and depression. The absence of atmosphere means there is no scattering of light, no soft blue sky. The sun would appear stark and brilliant against pure blackness, illuminating the landscape with intense clarity. It would feel less like dawn and more like a spotlight slowly revealing an ancient stage. And yet, despite its darkness, the Moon's surface carries a quiet beauty. The contrast between smooth Maria and rugged highlands creates patterns visible even from Earth with a small telescope. Those patterns have inspired stories and guided explorers. They are reminders that even in silence, landscapes can speak. Each crater tells of a collision long past, each mountain range marks the boundary of an ancient impact, each plain of dark basalt whispers of molten rock that once flowed freely before cooling into permanence. In this way, the Moon becomes a museum of the early solar system, its features preserved like exhibits behind invisible glass. It holds a record of the chaos that once dominated our cosmic neighborhood, offering scientists clues about planetary formation and evolution. Yet for all its scientific importance, it remains simply a glowing disk in the night sky to most of us, serene and familiar. When you look up and trace the dark shapes of the lunar seas, imagine the colossal impacts that shape them, the mountains rising along their edges, the silent dust that blankets everything in soft gray. Imagine standing there, beneath that endless black sky, surrounded by a landscape sculpted by time and gravity alone. In its stillness, the Moon's surface feels almost meditative, a reminder that even worlds born in fire and collision can settle into calm. And as we continue our gentle journey through sleepy science facts about moons, we carry with us the image of that silent terrain, patiently orbiting Earth, illuminated by sunlight, forever marked by the artistry of the cosmos. On a quiet shoreline at night, when the world feels hushed and the air carries the cool scent of salt, the ocean seems to breathe. Waves advance gently up the sand, pause as if considering their reach, and then retreat in a slow exhale. Hours later, the water will rise again, covering the same stretch of shore with calm determination. This rhythm, so steady and ancient, is guided not by wind alone but by the invisible pull of the moon. Though it hangs far above us, serene and silent, its gravity reaches down across the emptiness of space and touches every ocean on Earth. It does not tug sharply or violently, it draws the water with a subtle persistence, shaping tides that have pulsed across our planet for billions of years. Gravity is often imagined as a simple downward force, but in truth it is a mutual attraction between masses. The Earth pulls on the moon just as the moon pulls on the Earth. Because the moon is relatively close to us in cosmic terms, its gravitational influence creates a stretching effect on our planet. The side of Earth facing the moon experiences a slightly stronger pull, causing the oceans there to bulge outward. On the opposite side of the planet, another bulge forms due to inertia, as Earth itself is pulled slightly toward the moon while the water lags behind. The result is two high tides on opposite sides of the globe, with lower tides occurring in between. As Earth rotates beneath these bulges, coastlines move in and out of alignment with them, creating the familiar rise and fall of sea levels. This tidal dance is not perfectly uniform. The Sun, though much farther away, is vastly more massive and also contributes to tidal forces. When the Sun, Earth, and Moon align during a full or new moon, their combined gravitational pull produces especially strong tides known as spring tides. When the Moon and Sun form a right angle relative to Earth, during the first and third quarter phases, the tides are gentler, called neap tides. These variations are predictable, woven into the monthly rhythm of lunar phases. Long before satellites and scientific instruments, coastal communities learned to read these patterns, understanding that the moon's position could shape fishing, navigation, and daily life. Yet the influence of tides extends far beyond the shoreline. Tidal forces create friction between Earth's rotating surface and the ocean bulges, gradually slowing our planet's spin. Each century, Earth's day lengthens by a tiny fraction of a second. At the same time, conservation of angular momentum causes the moon to drift slowly farther away, increasing its orbital distance by about 3.8 centimeters per year. This quiet exchange of energy has been unfolding since the moon's formation, subtly reshaping the dynamics of our planet-satellite system. Billions of years ago, when the moon was closer, tides were stronger and days were shorter. The relationship between Earth and Moon has always been evolving, though so gradually that it feels eternal to us. Tides do not only affect oceans. The solid Earth itself experiences slight tidal bulges, rising and falling by a few centimeters as the moon passes overhead. Even the atmosphere responds, shifting in gentle patterns influenced by gravitational forces. These movements are subtle, almost imperceptible, yet they remind us that the moon's presence is not confined to the sky. It is woven into the physical fabric of our world. In 1969, when astronauts from the Apollo 11 mission stood upon the moon's surface, they looked back at Earth suspended in blackness, a blue sphere streaked with white clouds. From that vantage point, the oceans were visible as vast swaths of deep color, swirling and shifting. Though they could not see the tides directly, they knew that the gravitational connection between their boots and those waters was constant. The same force holding them lightly against the lunar surface was reaching across space to lift and lower the seas of their home planet. The moon's stabilizing role may be even more profound than its influence on tides. Earth's axial tilt, the angle at which it spins relative to its orbit around the Sun, remains relatively steady at about 23.5 degrees. This tilt gives us seasons, guiding cycles of warmth and cold that shape ecosystems and agriculture. Without the moon's gravitational stabilizing effect, Earth's tilt might wobble chaotically over time, leading to extreme climate variations. Some scientists believe that this steady tilt, maintained by the moon's presence, has played a crucial role in the development and persistence of life. In this sense, the moon is not merely a distant ornament, it is a guardian of balance. There is something deeply calming about recognizing this connection. The ocean's slow breathing at night is part of a larger cosmic exchange. The moon does not glow with its own light, yet it guides waters across continents. It does not speak, yet it shapes the rhythms of entire ecosystems. Shorebirds forage according to tidal schedules. Coral reefs rely on lunar cycles for synchronized spawning. Even certain species of plants and animals appear sensitive to the brightness of the full moon, adjusting behaviors in subtle response to its glow. If you were to sit quietly by the sea during a rising tide, you might feel the gentle inevitability of it. The water will reach its peak and then recede, only to return again. This pattern has repeated since long before humans walked the earth. It will continue long after we are gone. The moon, drifting slowly outward yet remaining bound by gravity, will keep guiding these rhythms. In the soft silver light of a full moon, the ocean surface shimmers as though stitched with threads of reflected sunlight. Each ripple carries the imprint of gravitational forces stretching invisibly through space. It is easy to forget that such everyday phenomena are tied to celestial mechanics, to orbital motion and mass and momentum. Yet that is the quiet wonder of it all. The tides are proof that even across hundreds of thousands of kilometers, bodies in space remain connected. The moon may seem distant, suspended against the stars, but its influence is intimate, touching coastlines, coral reefs, and the turning of our days. And as we continue drifting deeper into the science of moons, we carry this awareness with us, that the gentle rise and fall of water is a conversation between Earth and its silent companion, a rhythm written in gravity, unfolding endlessly beneath the calm glow of the night sky. If you could drift outward through the solar system, leaving behind the gentle pull of Earth and the familiar glow of our moon, you would eventually approach a giant striped sphere dominating the darkness, its presence immense and commanding. Jupiter is not just a planet. It is almost a miniature solar system of its own. Surrounding it are dozens of moons, each following its own orbit, each shaped by gravity and time, each carrying a story written in ice, rock, fire, and ocean. The scale of this system feels almost dreamlike. Jupiter's gravity is so powerful that it shepherds its moons in complex patterns, creating a celestial choreography that unfolds silently in the cold expanse of space. In 1610, when Galileo Galilei turned his telescope toward Jupiter, he noticed tiny points of light arranged near the planet. Over consecutive nights, those points shifted position. They were not distant stars, they were moons orbiting another world. This discovery changed humanity's understanding of the cosmos forever. If moons could orbit Jupiter, then not everything revolved around Earth. The universe suddenly felt larger, more dynamic, more humbling. The four largest of these moons, Io, Europa, Ganymede, and Callisto, are now known as the Galilean moons, and each one is extraordinary in its own quiet way. Io is a world of fire. Though it appears small beside Jupiter's vast bulk, it is the most volcanically active body in the entire solar system. Its surface is mottled with yellows, oranges, and deep reds, colors produced by sulfur compounds ejected from erupting volcanoes. These eruptions are not fueled by internal heat alone but by tidal forces. Jupiter's immense gravity stretches and compresses Io as it orbits, generating friction within its interior. This tidal heating keeps its core hot and its surface restless. From orbit, spacecraft have captured images of towering plumes rising hundreds of kilometers above Io's surface, arcs of molten material falling back under weak gravity. It is a world in constant transformation, sculpted by gravitational stress. Europa, by contrast, appears serene. Its surface is covered in smooth, bright ice crisscrossed by dark lines like delicate fractures in glass. Beneath that frozen shell, scientists believe there may be a vast global ocean of liquid water. Tidal forces from Jupiter and neighboring moons gently flex Europa's interior, generating enough warmth to keep water from freezing solid. This hidden ocean may contain more water than all of Earth's oceans combined. The thought is quietly astonishing. Beneath an icy crust, far from the warmth of the sun, an ocean may exist in darkness. Some scientists consider Europa one of the most promising places to search for life beyond Earth. In that silent sea, warmed by gravitational energy rather than sunlight, chemistry may be unfolding in ways we are only beginning to imagine. Then there is Ganymede, the largest moon in the solar system, even bigger than the planet Mercury. It possesses its own magnetic field, a rare and remarkable feature for a moon. Its surface displays a patchwork of ancient craters and younger grooved terrain, evidence of geological processes that once reshaped its crust. Beneath its icy exterior, it too may harbor subsurface oceans layered between sheets of ice. Ganymede feels like a planet in miniature, complex and layered, quietly orbiting its giant parent. Callisto, the outermost of the four, carries a different kind of story. Its surface is heavily cratered, more ancient and unchanged than those of its siblings. It bears the marks of countless impacts, preserved over billions of years. Unlike Io or Europa, Callisto shows little evidence of internal heating or active geology. It is a time capsule, a frozen archive of the early solar system. Standing upon it, if one could, you would see a landscape saturated with craters overlapping in intricate patterns, each one a reminder of collisions long past. Together, these four moons create a delicate gravitational resonance. Io completes 4 orbits for every 2 of Europa and 1 of Ganymede. This synchronized pattern maintains tidal heating within their interiors, shaping their geological activity. It is a cosmic rhythm, precise and enduring, maintained by gravity's invisible hand. Jupiter's smaller moons add even more complexity, some captured asteroids, others fragments from ancient collisions. The entire system feels alive with motion, yet it unfolds in profound silence. When spacecraft such as Juno approach Jupiter, they must navigate intense radiation belts generated by the planet's powerful magnetic field. These missions send back images of swirling storms and luminous auroras dancing at Jupiter's poles. In the background of many of these photographs, a moon drifts quietly past, a small world silhouetted against striped clouds. Each of those moons experiences eclipses, shadowed by Jupiter's bulk, then re-emerging into sunlight. Their days and nights are shaped not only by the sun but by their giant host. There is something deeply calming about imagining this system in motion. Jupiter spins rapidly, completing a rotation in just under 10 hours, while its moons circle in measured arcs. Sunlight filters faintly across their surfaces, reflecting off ice, rock, and volcanic plains. Though the environment is harsh, radiation intense, temperatures frigid, the beauty of the arrangement is undeniable. These are not mere satellites. They are diverse worlds, each with landscapes and histories as rich as small planets. As we drift gently through this sleepy exploration of moons, Jupiter's system reminds us that our own moon is only one example among many. Across the solar system, moons come in countless forms: fiery, icy, ancient, and dynamic. They are companions to planets, shaped by gravity's patient guidance. And far from Earth's quiet shoreline tides, these distant moons continue their silent revolutions, circling a giant world in a dance that has lasted billions of years, illuminated faintly by sunlight that traveled across vast distances to reach them. Far beyond the orbit of Jupiter, drifting deeper into the outer solar system where sunlight grows softer and more distant, there is another giant world wrapped in elegance. Saturn appears almost delicate from afar, encircled by luminous rings that seem too graceful to belong to a planet of such immense size. These rings, made of countless fragments of ice and rock, shimmer faintly in reflected sunlight, forming thin, bright bands that stretch hundreds of thousands of kilometers outward. And within this breathtaking system of rings moves a collection of moons, each one quietly orbiting in harmony. Among them is Titan, a moon so intriguing and complex that it feels like a world pulled from science fiction, yet it is entirely real, drifting patiently around its golden parent. Titan is the largest moon of Saturn and the second largest moon in the entire solar system. It is even bigger than the planet Mercury. But what makes Titan extraordinary is not only its size, it is its atmosphere. Titan possesses a thick, hazy envelope of nitrogen-rich air, denser than Earth's atmosphere, veiling its surface beneath layers of orange smog. For centuries, Titan was little more than a distant dot of light. But when spacecraft began to approach Saturn in the late 20th and early 21st centuries, a new picture emerged. In 2005, the European Space Agency's Huygens probe descended through Titan's atmosphere, carried there by NASA's Cassini-Huygens mission. As it drifted downward, parachuting slowly toward the hidden surface, it transmitted images that revealed river channels, rounded pebbles, and landscapes shaped by flowing liquid. But these rivers were not made of water. On Titan, temperatures are so cold that water ice behaves like rock, solid and unyielding. Instead, methane and ethane exist in liquid form, carving valleys and filling lakes. Titan has methane clouds, methane rain, and methane seas. Vast bodies of liquid hydrocarbons gather near its poles, reflecting faint sunlight under an orange sky. It is a world both alien and strangely familiar, with weather patterns, seasonal cycles, and a hydrological system, yet one built from chemistry entirely different from Earth's. Standing on Titan, if such a thing were possible without a pressurized suit and heated protection, the sky above would appear thick and dim, sunlight filtered through layers of haze. Saturn itself would hang in the heavens, enormous and luminous, its rings forming a radiant arc across the sky. The gravity would feel lighter than Earth's, allowing gentle, floating movements. In that muted landscape, rivers of methane would wind across icy terrain, pooling into dark lakes under a persistent chill. It is one of the most Earth-like environments beyond our planet, yet profoundly different in substance and scale. Scientists are captivated by Titan because its atmosphere may resemble conditions that existed on early Earth before life emerged. Complex organic molecules form in its upper atmosphere as sunlight breaks apart methane and nitrogen, triggering chemical reactions. These molecules drift downward like slow snow, settling on the surface. In this cold laboratory, chemistry unfolds quietly, perhaps hinting at pathways that once led to life on our own world. Titan does not promise answers easily, but it invites questions that feel almost philosophical. How does life begin? What ingredients are necessary? Could entirely different chemistries produce something alive? Saturn's other moons add further texture to this serene system. Enceladus, though small, astonished scientists when geysers of water vapor were discovered erupting from its south pole, spraying icy particles into space. These plumes suggest a subsurface ocean beneath its frozen crust, warmed by tidal forces much like Europa around Jupiter. The material from Enceladus even contributes to one of Saturn's rings, linking moon and planet in an ongoing exchange. Each moon participates in this gravitational ballet, orbiting with precision, occasionally casting shadows upon Saturn's cloud tops or slipping through the planet's vast rings. The rings themselves may be temporary on cosmic timescales. Though they appear eternal to us, scientists believe they could gradually disperse over millions of years, their particles pulled inward by Saturn's gravity or scattered outward. Some theories suggest the rings may have formed from the remnants of a shattered moon, broken apart by tidal forces when it ventured too close. If so, then Saturn's most iconic feature may be the memory of a former companion, spread into luminous arcs circling the planet. As the Cassini-Huygens mission concluded in 2017, the spacecraft performed a final series of daring orbits before plunging into Saturn's atmosphere, ensuring it would not contaminate moons like Titan or Enceladus. Its final images remain some of the most breathtaking ever captured. Saturn's rings backlit by sunlight, casting long shadows, Titan drifting like a hazy lantern nearby. These images carry a quiet emotion, a sense of farewell to a system that feels almost storybook in its beauty. In the stillness of the outer solar system, Saturn and its moons continue their silent revolutions. Titan's methane rains fall gently onto icy plains. Enceladus releases shimmering plumes into space. The rings glow softly in reflected sunlight. And though they are hundreds of millions of kilometers away, these distant worlds feel strangely close when we learn their stories. They remind us that moons are not simple rocks orbiting planets. They are dynamic environments, shaped by gravity and chemistry, holding secrets beneath their surfaces. As we drift deeper into this sleepy exploration of moons, Saturn's realm offers a different kind of wonder, one of atmosphere and haze, of liquid methane seas and icy geysers, of rings that shimmer like fragile halos. In the vast silence of space, these worlds continue their graceful motion, illuminated faintly by a distant sun, whispering stories of possibility across the cold expanse of the cosmos. Far beyond the warm inner planets, beyond the asteroid belt, past the towering presence of Jupiter and the elegant rings of Saturn, And even beyond the tilted blue-green world of Uranus, there drifts a deep sapphire planet wrapped in supersonic winds and quiet mystery. Neptune orbits at the edge of the classical solar system, where sunlight is faint and time seems to move more slowly. Out here, 1 year on Neptune lasts 165 Earth years. The sun appears as a bright star rather than a dominating disk, and the temperature drops to extremes that challenge imagination. And yet, even in this distant frontier, moons continue their silent revolutions. Among them is Triton, a world so unusual that it may not have been born beside Neptune at all. Triton is Neptune's largest moon, and from the moment it was discovered in 1846, just weeks after Neptune itself was identified, it stood apart. Triton orbits Neptune in a retrograde direction, meaning it moves opposite to the planet's rotation. This detail may seem subtle, but in celestial mechanics it is profound. Most moons form from the same rotating disk of material as their parent planet, orbiting in the same direction. Triton's backward path suggests a different origin, one that begins far beyond Neptune's gravitational reach. Scientists believe Triton was once an independent object, likely formed in the Kuiper Belt, the distant region of icy bodies that includes dwarf planets like Pluto. At some point in the distant past, Triton ventured too close to Neptune and was captured by its gravity. Such a capture would not have been gentle. The gravitational interaction likely generated enormous tidal forces, heating Triton's interior and reshaping its orbit over time. Eventually, the orbit settled into the stable but retrograde path we observe today. In this way, Triton is not simply a moon, it is a captured wanderer, a former drifter now bound to a giant world. When the spacecraft Voyager 2 flew past Neptune in 1989, it provided humanity with the first close-up images of Triton. What it revealed was astonishing. Instead of a frozen, inactive surface, Triton displayed signs of activity. Dark streaks marked its icy plains, evidence of nitrogen geysers erupting from beneath the surface. These plumes rose several kilometers into the thin atmosphere before drifting downwind, leaving trails across the terrain. In a region of space where sunlight is weak and temperatures are brutally cold, Triton was unexpectedly alive with motion. The surface of Triton is a landscape of frozen nitrogen, methane, and water ice. Vast smooth plains stretch across its surface, interrupted by strange formations known as cantaloupe terrain, named for their resemblance to the textured rind of a melon. These rounded depressions form patterns unlike anything seen on other moons. There are also large icy volcanoes, known as cryovolcanoes, that may have once erupted slushy mixtures of water and ammonia instead of molten rock. In Triton's frigid environment, water ice behaves like stone, and nitrogen becomes a volatile substance capable of driving atmospheric changes. One of Triton's most fascinating qualities is its thin atmosphere, composed mainly of nitrogen. Though far more tenuous than Earth's, it is enough to create weather. Seasons occur as Triton orbits Neptune, though each season lasts decades due to Neptune's long year. As sunlight shifts across the surface, nitrogen ice can sublimate directly into gas, creating winds and altering surface features. Even at the solar system's edge, dynamic processes unfold quietly. Triton's retrograde orbit has another consequence. Over immense spans of time, tidal interactions with Neptune are slowly drawing Triton closer to the planet. Unlike our moon, which is gradually drifting away from Earth, Triton is spiraling inward. Billions of years from now, it may cross a boundary known as the Roche limit, where Neptune's gravity could tear it apart. If that happens, Triton might break into fragments, forming a brilliant ring system around Neptune. In this distant future scenario, Neptune could gain rings similar in grandeur to Saturn's, formed from the remains of its captured moon. There is something quietly poignant about that possibility. Triton, once a wanderer of the outer solar system, captured into orbit, may one day dissolve into a luminous halo. Its story spans capture, transformation, and eventual disintegration. Yet for now, it continues its slow retrograde journey, geysers occasionally venting into the thin air, icy plains reflecting faint sunlight. Standing on Triton, if one could endure the cold, the sky would appear dim and bluish, with Neptune looming enormous overhead, a vast azure globe filling much of the horizon. The sun would be a distant star, casting a weak glow across frozen ground. Silence would dominate, broken only by the whisper of nitrogen winds. It would feel like standing at the edge of the solar system, where the familiar warmth of the inner planets fades into deep cosmic night. And yet, even here, there is movement, energy, and change. Moons are not confined to the realms of Jupiter and Saturn. They extend outward to the very frontier, orbiting planets that circle in slow arcs around a distant Sunday. Triton reminds us that moons can be captured travelers, reshaped by gravity and time, holding on to traces of their origins in far-off regions of space. As we continue this gentle exploration of sleepy science facts about moons, Triton's quiet orbit offers a different kind of wonder. It is the wonder of distance, of cold beauty, of a world shaped by forces that span billions of years. In the faint glow of the outer solar system, Triton circles Neptune in reverse, a silent companion drifting through darkness, carrying the memory of a journey that began long before it ever became a moon. Far out in the quiet blue depths beyond Saturn, where sunlight softens into a pale glow and the cold becomes more absolute, there drifts a planet unlike any other. Uranus rolls through space tipped dramatically onto its side, its axis tilted by about 98 degrees. Instead of spinning upright like Earth or even slightly angled like Mars, Uranus rotates almost horizontally, as if it had once been nudged by a colossal force and never quite recovered its balance. Around this sideways world circles a family of moons, each one following paths that mirror the planet's unusual orientation, creating one of the most quietly strange systems in our solar system. The tilt of Uranus likely resulted from an ancient collision, perhaps with an Earth-sized object during the early days of planetary formation. That impact may have reshaped not only the planet's rotation but also the arrangement of its rings and moons. Today, Uranus spins on its side as it orbits the Sun, causing its poles to experience extreme seasons. For decades at a time, one pole faces the Sun continuously while the other remains in prolonged darkness. Its moons share in this unusual seasonal rhythm, moving through long stretches of sunlight and shadow in ways unlike the moons of any other planet. Among Uranus's many satellites, 5 major moons stand out: Miranda, Ariel, Umbriel, Titania, and Oberon. Their names come not from ancient mythology like many other moons, but from characters in the works of William Shakespeare and Alexander Pope. There is something fitting about that literary origin, as these moons feel almost theatrical in their individuality, each displaying landscapes that hint at dramatic histories beneath their frozen surfaces. Miranda is perhaps the most astonishing. Small and irregularly shaped, it appears at first glance like a patchwork world stitched together from mismatched pieces. Enormous cliffs rise abruptly from its surface, including Verona Rupees, one of the tallest known cliffs in the solar system, plunging up to 20 kilometers downward. The terrain seems fractured and rearranged, as if Miranda were shattered long ago and then gently reassembled by gravity. Scientists suspect tidal forces from Uranus may have heated its interior in the past, causing partial melting and resurfacing. The result is a moon that looks sculpted by forces both violent and creative, a frozen mosaic orbiting silently in a tilted sky. Ariel, brighter and smoother than Miranda, shows signs of extensive resurfacing. Long valleys and ridges stretch across its icy plains, suggesting tectonic activity in its past. Umbriel, darker and more heavily cratered, carries the appearance of an older, less active world, its surface marked by impacts preserved in the absence of erosion. Titania and Oberon, the 2 largest moons of Uranus, bear canyons and fault lines that hint at internal expansion long ago, possibly driven by freezing water beneath their crusts. As internal oceans solidified, they may have pushed outward, cracking the surface and leaving behind vast chasms that remain etched into the ice. The entire Uranian system moves in alignment with the planet's tilt. Imagine standing on one of these moons during a long summer season, watching the sun hover near the horizon for years at a time. The light would be faint, tinted by distance, yet persistent. Then imagine the slow transition into a winter that lasts decades, when darkness envelopes the landscape and only distant stars provide illumination. These extended seasons shape temperature patterns and perhaps even the internal evolution of the moons themselves. When Voyager 2 flew past Uranus in 1986, it provided humanity with the only close-up images we currently possess of this tilted system. The spacecraft revealed pale blue clouds drifting across Uranus's atmosphere and captured detailed views of its moons, exposing cliffs, craters, and fractured plains. Yet the encounter was brief. Voyager 2 continued onward, leaving Uranus and its family of moons largely unexplored since then. Much about this system remains uncertain, waiting quietly for future missions to return. The idea of subsurface oceans beneath icy crusts has become a recurring theme among moons of the outer solar system, and some scientists suspect that Titania or Oberon may harbor such hidden layers. If so, even these distant satellites, bathed in dim sunlight, could contain environments where chemistry unfolds beneath thick ice. The thought is gentle yet profound. Warmth may exist not only near the sun but deep within worlds shaped by tidal forces and radioactive decay. Uranus itself appears serene from a distance, a smooth sphere of turquoise light, its faint ring system encircling it like delicate threads. Yet its extreme tilt makes it a planet of quiet extremes, and its moons follow this pattern. They orbit in a plane nearly perpendicular to the rest of the solar system, as though they exist in their own orientation, slightly apart from the familiar alignment of planets. As we drift calmly through this exploration of moons, the Uranian system offers a sense of quiet uniqueness. It reminds us that planetary systems need not conform to a single pattern. Some tilt dramatically, some capture wandering objects, some ignite volcanic activity through tidal stress. In the vast silence of space, diversity flourishes. Miranda's towering cliffs, Ariel's smooth valleys, Titania's ancient canyons, all revolve around a planet that spins on its side, bathed in distant sunlight. And in that distant, tilted family, time moves gently. Seasons stretch across decades, sunlight lingers or withdraws for years, and icy landscapes hold their shapes in near-perfect preservation. The moons of Uranus circle patiently, illuminated by a faint sun and guided by gravity's steady hand, reminding us that even at the solar system's far reaches, there is rhythm, structure, and quiet beauty waiting in the cold. Beyond Neptune, at the very edges of the classical solar system, lies a realm of shadows and frozen silence, the Kuiper Belt. Here, sunlight is faint and the cold reaches extremes so absolute that water ice becomes as hard as stone, methane and nitrogen freeze solid, and the smallest impact can leave a lasting mark. Within this quiet frontier, dozens of small worlds drift in slow arcs around the sun, many of them carrying their own tiny moons. These dwarf planet systems are subtle, almost hidden compared to the bright giants of the inner system, yet they reveal the quiet artistry of gravity and time in the far reaches of space. Consider Pluto, once classified as the 9th planet and now known as the largest member of the Kuiper Belt. Pluto is not alone. It has 5 known moons, with Charon being the largest. Charon is massive relative to Pluto, so much so that the two bodies orbit a common center of mass located outside Pluto itself. From this perspective, Pluto and Charon almost feel like a double planet, locked in an elegant gravitational embrace. Their mutual orbit takes about 6.4 Earth days, and because both bodies are tidally locked to each other, the same faces always turn toward one another, creating a quiet, intimate cosmic partnership. Pluto's other moons, Styx, Nix, Kerberos, and Hydra, are smaller and more irregularly shaped, but each contributes to the intricate dance of the system. They orbit in nearly circular paths, maintaining resonances that prevent collisions and preserve long-term stability. Their surfaces are icy and cratered, reflecting the history of a distant region still shaped by impacts and the subtle gravitational tugs of their neighbors. In photographs returned by NASA's New Horizons mission, these moons appear as quiet companions circling in perfect rhythm, shadows passing across Pluto's surface, illuminated by the faint sun of the outer solar system. Beyond Pluto, other dwarf planets carry moons of their own. Haumea, known for its elongated shape and rapid spin, has 2 small satellites, Namaka and Hyakka, moving in precise orbits around its equatorial plane. Eris, slightly smaller than Pluto, has its companion Dysnomia, quietly orbiting in darkness far from the sun. Even Makemake, one of the more distant Kuiper Belt objects, has at least one tiny moon, discovered only through careful observation of stellar occultations. These satellites, often overlooked in popular imagination, are integral to understanding the history and dynamics of their parent worlds. The moons of these distant dwarfs are frozen archives. Their surfaces carry traces of ancient impacts, subtle shifts in ice, and patterns shaped over billions of years. Unlike the dramatic volcanic activity of Io or the methane lakes of Titan, these moons are quiet, preserved in deep cold. Yet even in their seeming stillness, gravitational forces create motion. Tidal effects may flex interiors, affecting potential subsurface layers, while orbital resonances guide paths that have endured over eons. In observing these systems, we see the universe's quieter side. Not every moon erupts with volcanic fury, nor every planet glows with towering storms. Some moons exist in understated motion, their stories told in orbits, shadows, and icy plains. Charon's steadfast orbit around Pluto, Namaka and Hyakka's elegant circling of Haumea, Dysnomia's distant journey around Eris, all are examples of celestial choreography written over billions of years, unfolding so slowly that human eyes might notice little more than a faint point of light in a telescope. And yet, in that subtlety lies serenity. These moons remind us that motion does not always need drama to inspire awe. Their silence is not emptiness but quiet persistence, a gentle rhythm extending across billions of kilometers. The outer solar system is not void. It is a realm of patient orbits, frozen landscapes, and light that has traveled for hours to reach even the most sensitive detectors. If you could drift among these distant worlds, you would feel a stillness unlike any other. The faint sun would cast long shadows across icy plains. Craters and ridges would remain undisturbed for millennia. Each moon would move steadily in its orbit, a small companion to a small world, yet integral to the story of the solar system's formation. In this sleepy, distant frontier, moons exist almost as echoes of planets, tiny markers of order in the cold cosmic night. They are companions, guardians of ancient landscapes, and reminders that even at the limits of sunlight, gravity continues its quiet work. As we continue our gentle journey through the science of moons, these distant dwarf satellites offer a sense of peaceful wonder, showing that the outer reaches of the solar system are alive with motion, even when that motion is slow, deliberate, and silent. Every night, when the sky darkens and the first stars appear, the moon begins its quiet performance, cycling through shapes both familiar and subtle. From Earth, we see its face changing slowly over the course of a month, from a thin crescent to a glowing full disk, then waning back to darkness. These transformations are not magical but are the result of geometry, light, and the moon's steadfast orbit around our planet. Yet the effect is mesmerizing, comforting, and endlessly engaging, drawing humans to look upward for millennia and ponder the rhythm of time. The lunar phases occur because the moon does not produce its own light. Instead, it reflects the sun's rays, and the portion visible to us changes as the moon orbits Earth. When the moon is between Earth and the sun, the near side faces away from us, and we see a new moon. As it moves along its orbit, sunlight gradually illuminates a growing portion of its face, creating the waxing crescent. By the first quarter, half of the visible hemisphere is bathed in light. Soon, the moon reaches full illumination, the full moon, when Earth lies roughly between the moon and sun, allowing the entire near side to glow. Then comes the waning phase, a slow retreat of light, fading back toward the new moon. This cycle repeats approximately every 29.5 days, creating a rhythm that has guided calendars, festivals, and quiet reflection throughout human history. The changing light creates more than aesthetic beauty. Shadows cast by lunar craters, ridges, and mountains shift gradually, revealing new textures and depths on the moon's surface. A crater rim might appear as a subtle line one night and as a deep shadow the next. Mare regions, the ancient basalt plains, catch sunlight differently depending on the angle, sometimes glowing softly, sometimes appearing almost inky. Observing the moon at different phases allows astronomers to study its topography in detail, noting subtle differences in height, depth, and composition. The full moon holds a special place in culture and imagination. Its brightness is unmatched, illuminating the landscape with silver light, elongating shadows, and creating an almost dreamlike atmosphere. For centuries, writers, poets, and dreamers have described its calming yet stirring effect, attributing moods and mysteries to its presence. During this time, tides on Earth are slightly stronger, called spring tides, a gentle reminder of the moon's invisible pull. Even without scientific understanding, humans have sensed its quiet influence. Crescent moons offer a different kind of serenity. When the moon is a thin sliver, it seems delicate, as though poised on the edge of emergence. Observers often describe a feeling of anticipation when glimpsing a crescent in the evening sky, a promise that light will grow over the coming nights. Similarly, the waning phases, fading into darkness, bring a sense of closure, reflection, and rest. The moon's changing face mirrors natural cycles: growth and retreat, light and shadow, presence and absence. Eclipses add a layer of drama to this gentle cycle. A lunar eclipse occurs when Earth passes between the sun and moon, casting a shadow that slowly envelopes the lunar surface. During a total eclipse, the moon glows with a subtle reddish hue, a phenomenon caused by sunlight filtering through Earth's atmosphere. This blood moon is breathtaking, a reminder of cosmic alignments and the interconnectedness of celestial bodies. Solar eclipses, when the moon passes between Earth and the sun, are equally mesmerizing, casting fleeting shadows across the land. Both events emphasize the precise motion of celestial mechanics, a quiet choreography unfolding without pause. Observing lunar phases can also have practical significance. Ancient civilizations used them to track time, plan agricultural cycles, and navigate the seas. Even today, photographers, astronomers, and casual stargazers find value in noting the moon's shape, timing events, and marveling at the slow transformation. The moon's phases provide a tangible sense of continuity and rhythm, a nightly companion whose changes are predictable yet endlessly fascinating. From a meditative perspective, the cycle is calming. Watching a waxing crescent grow or a full moon climb the night sky encourages mindfulness, a gentle awareness of the passage of time. Its light softens the darkness, creating a sense of connection between Earth and its silent companion. The moon's transformation is slow, deliberate, and peaceful, perfect for reflection, relaxation, and gentle contemplation. As we continue our journey through sleepy science facts about moons, the phases remind us of a simple truth: change does not need to be rapid to be profound. The moon's patient movement, its subtle shifts in light and shadow, and its predictable yet enchanting rhythm invite us to pause, observe, and breathe. It is a nightly performance, a dance of illumination and darkness, a quiet companion guiding us through the slow, comforting cycles of the cosmos. On rare nights, the calm, familiar face of the moon undergoes a transformation that feels both gentle and extraordinary. A lunar eclipse occurs when Earth drifts directly between the sun and the moon, casting a shadow across the lunar surface. Unlike the fleeting brightness of a meteor or the sudden flare of a distant nova, a lunar eclipse unfolds slowly, deliberately, over the course of hours. Its progress is quiet yet mesmerizing, a celestial performance that invites contemplation and awe. During the initial phase, the Earth's penumbra, the partial outer shadow, begins to touch the moon. At first, the effect is subtle, a slight dimming along one edge of the lunar disk. As the moon continues its orbit, the darker umbra gradually creeps across its surface, creating a gentle gradient from light to shadow. Observers often describe this stage as calming, almost meditative, as the moon's familiar brightness softens in measured stages. When the moon is fully engulfed in Earth's umbra, totality is reached. The moon does not vanish into darkness. Instead, it glows with a warm, coppery red hue. This phenomenon, sometimes called a blood moon, occurs because sunlight passing through Earth's atmosphere is scattered and refracted, allowing only longer red wavelengths to illuminate the lunar surface. The effect is subtle yet profound, bathing the moon in a surreal glow that seems suspended between night and day. For centuries, humans have watched this transformation, interpreting it as portent, omen, or divine signal, yet in truth it is a simple interplay of light, shadow, and geometry. Each eclipse is unique. The depth of red, the subtle gradations across the moon, and the surrounding sky's darkness all depend on Earth's atmospheric conditions at the time. Dust, clouds, or volcanic ash can intensify or soften the coloration, giving each lunar eclipse a distinct character. Observing this slow change is inherently relaxing, the hours passing almost unnoticed as the moon drifts through shadow. It is a perfect example of cosmic patience, a reminder that the universe operates on scales far beyond human urgency. Even partial eclipses offer fascination. When only a portion of the moon enters Earth's shadow, the contrast between bright and dark regions accentuates craters, ridges, and the moon's maria. Shadows stretch across the surface, revealing depth and detail invisible under ordinary illumination. It is as if the moon is offering a quiet lesson in topography, guiding observers to notice nuances normally overlooked. The geometry behind lunar eclipses is simple but elegant. Earth's orbit and the moon's orbit are slightly tilted relative to each other, which is why eclipses do not occur every month. Only when the three bodies align precisely, near the points where the orbital planes intersect, does an eclipse take place. This rarity adds to their charm, creating anticipation and a sense of cosmic order. Astronomers can predict them decades in advance, yet each eclipse retains its quiet magic for those who witness it. From a meditative perspective, lunar eclipses encourage stillness. The slow transition from light to deep red and back again draws attention to the passage of time in a gentle, almost hypnotic manner. Unlike fast-moving events, such as meteor showers, an eclipse allows prolonged observation, letting viewers connect with the vast scales of space and the patience of celestial mechanics. Historically, lunar eclipses have inspired myths, rituals, and art. Ancient civilizations recorded them meticulously, recognizing the moon's periodic transformation as both mysterious and reliable. Today, the science behind eclipses enriches rather than diminishes their beauty. Understanding the role of Earth's shadow and atmospheric scattering does not remove wonder. It adds a layer of appreciation for the subtle interplay of physics that creates such serene visual spectacles. The calming aspect of a lunar eclipse also lies in its predictability. The moon will emerge from Earth's shadow, slowly regaining its full glow, as if completing a quiet journey through darkness. This return to familiar brightness reinforces a sense of continuity, rhythm, and cosmic balance. As we drift through the science of moons in this sleepy journey, lunar eclipses stand as reminders of the quiet forces shaping our night sky. Shadows move slowly, light bends gently through Earth's atmosphere, and the moon performs a transformation that is both spectacular and soothing. It is a lesson in patience, a moment to breathe, and a celestial lullaby played in coppery red across the vast, silent theater of space. While lunar eclipses bathe the moon in the gentle shadow of Earth, solar eclipses offer a very different spectacle, a fleeting moment when the moon itself passes between Earth and the sun, casting its shadow upon our world. Unlike the slow and meditative pace of a lunar eclipse, a solar eclipse unfolds rapidly, yet it retains a serenity that captivates and calms those fortunate enough to witness it. The event is rare for any single location, creating a sense of anticipation and quiet wonder that resonates deeply with human perception of time and cosmic alignment. The first hint of an eclipse appears as a subtle darkening along the sun's edge. Over minutes, the moon advances, gradually covering the bright disk. As the sun is obscured, daylight softens, shadows sharpen, and the world seems to pause in hushed expectation. Birds often quiet, winds shift, and an unusual stillness blankets the landscape. Unlike the continuous glow of daylight, the dimming of a solar eclipse has a surreal, almost ethereal quality. Observers may feel suspended between day and night, as if time itself has slowed to accommodate the celestial performance above. When the moon covers the sun entirely, totality is reached, revealing the sun's corona, a halo of plasma extending millions of kilometers into space, glowing faintly against the blackened sky. The corona is delicate and intricate, streaming outward like fine tendrils of light. It is simultaneously powerful and gentle, a luminous reminder of processes that fuel life on Earth yet exist far beyond our immediate perception. During totality, the sky darkens enough that stars become visible, and planets like Venus may glimmer nearby, creating a quiet cosmic tableau in which Earth's inhabitants become witnesses to celestial choreography. Partial solar eclipses offer a subtler beauty. As crescents of sunlight peek around the moon's edge, patterns form on the ground through gaps in leaves, creating natural pinhole projections. This soft dappled light gently flickers as branches sway, adding a dynamic, almost meditative quality to the experience. Unlike direct sunlight, these filtered rays invite quiet observation, contemplation, and a sense of connection with the rhythm of the cosmos. The geometry behind a solar eclipse is precise. The moon and sun appear roughly the same size in the sky because the moon is about 400 times smaller than the sun but also about 400 times closer to Earth. This remarkable coincidence allows for perfect alignment during total eclipses, a delicate balance between scale and distance. Scientists understand the mechanics, yet the experience of witnessing the event remains magical, evoking awe and calm in equal measure. Historically, solar eclipses inspired both fear and reverence. Ancient cultures interpreted them as signs from deities or omens of change. Today, while we understand the physics, the emotional impact persists. People travel great distances to witness the fleeting totality, experiencing a shared sense of wonder and stillness. The sudden dimming of the world, followed by a gradual return of sunlight, is a gentle reminder of continuity, rhythm, and cosmic order. Solar eclipses also emphasize the moon's intimate connection with Earth. Its gravitational presence shapes tides and stabilizes Earth's tilt, and its physical size and orbit allow it to participate in these rare, serene events. Observing a solar eclipse is not only witnessing an alignment of three celestial bodies but also sensing the moon's subtle influence on the rhythms of our planet. Even after the sun re-emerges fully, the lingering memory of the corona and the soft shadows left behind fosters a quiet sense of reflection. The rapid passage of the moon's shadow contrasts with the slow evolution of lunar phases, yet both events highlight patience, cycles, and the interplay of light and shadow. In their own ways, they encourage mindfulness, a gentle acknowledgement of humanity's place in the vast, precise ballet of the solar system. As we continue our serene journey through sleepy science facts about moons, solar eclipses offer a reminder that even fleeting moments can be deeply calming. The moon's shadow moves silently across Earth, light softens, and the natural world pauses. It is a gentle celestial lullaby, an ephemeral display of cosmic harmony, inviting observers to breathe, marvel, and sink into the quiet rhythm of the universe. Beneath the serene glow of the moon's familiar face lies a world that is quietly alive. Though it may seem static from Earth, the lunar surface experiences tremors known as moonquakes. Unlike Earth's earthquakes, which are often sudden and destructive, moonquakes are subtle, gentle vibrations that ripple through the moon's crust with a hushed persistence. They are a reminder that even celestial bodies appearing still and silent are subject to forces that shape their interiors over eons. Moonquakes were first detected in the late 1960s and early 1970s by the seismometers placed on the lunar surface by astronauts during the Apollo missions. These instruments recorded faint tremors originating from deep beneath the surface, some caused by tidal forces exerted by Earth's gravity, others by meteorite impacts or thermal expansion of the crust. Deep moonquakes, associated with the gravitational pull of Earth, follow predictable patterns, occurring roughly when the moon is closest to Earth in its elliptical orbit. The moon experiences several types of quakes. Deep moonquakes, while subtle, are persistent and rhythmic, echoing the steady pull of Earth's gravity. Shallow moonquakes, however, can be more intense, equivalent in energy to a moderate earthquake on Earth. Though rare, they have the potential to create small surface fissures or shift loose regolith, the fine layer of lunar dust covering much of the terrain. Even these quakes, though, are far less destructive than their terrestrial counterparts, offering a quiet reminder of the moon's dynamic interior rather than a threat. Thermal moonquakes add another layer of motion. The moon's surface undergoes extreme temperature changes between day and night, swinging hundreds of degrees Celsius. As sunlight warms the surface, materials expand. During the long, frigid lunar night, contraction occurs. These thermal stresses slowly flex the crust, producing small tremors that are subtle yet continuous, part of a silent cycle of contraction and expansion. Volcanic activity, long absent on the moon's surface, also played a role in its internal movements. Ancient lava flows and basaltic plains, visible from Earth as dark Maria, were formed billions of years ago. Though volcanic eruptions ceased long before humans arrived, the cooling and solidifying of these layers continues to produce minor stress within the crust. Over immense timescales, these stresses interact with tidal and thermal forces, creating a quiet network of energy moving beneath the lunar surface. Moonquakes are not merely geological curiosities. They help scientists understand the moon's internal structure. By studying the vibration's speed and patterns, researchers can infer the thickness of the crust, the composition of the mantle, and even the size of the lunar core. The moon, often seen as a passive, frozen satellite, reveals itself to be subtly alive through these hidden tremors, communicating its inner workings to those patient enough to listen. The moon's vibrations also underscore its connection with Earth. Tidal forces not only shape our oceans but also flex the moon itself, linking our two worlds in a delicate gravitational dance. Deep moonquakes peak at specific points in this lunar cycle, a rhythmic reminder of the invisible threads tying Earth and moon together. This quiet influence, imperceptible without instruments, highlights the cosmic harmony that governs both terrestrial and lunar motions. Imagine standing on the moon's surface, under the soft glow of the Earth hanging in the sky. The regolith beneath your feet feels solid, almost timeless, yet somewhere below, faint vibrations course through the crust. These subtle movements are slow and calm, far gentler than any terrestrial tremor, but they exist, proof that the moon is not entirely still. The knowledge can inspire a meditative sense of connection, a realization that life, or motion, persists even in apparent quietude. Moonquakes also hint at the possibilities for future exploration. Understanding the moon's internal stresses is crucial for constructing habitats or equipment that must endure its environment. Even as humans plan long-term lunar presence, these subtle tremors will shape the way we interact with this satellite, guiding engineering, architecture, and our understanding of planetary geology. In the quiet hours of a lunar night, when the sky above Earth is dark and the moon glows softly, one can imagine these tremors gently reverberating beneath the surface. They are a silent heartbeat, a rhythmic whisper of motion, connecting Earth and moon, past and present, observation and understanding. In their subtlety, moonquakes remind us that calm does not mean lifelessness. Even in apparent stillness, forces are at work, shaping the cosmos in ways both slow and profound, offering a gentle, continuous lullaby of motion beneath the serene glow of the night sky. Beneath the serene, silver glow of the moon's surface lies a landscape unlike any on Earth, a vast, powdery expanse known as regolith. This lunar soil, composed of tiny fragments of rock, dust, and glassy particles, blankets the moon in muted grays and subtle textures. From a distance, it appears smooth and unbroken, but up close, it is a complex tapestry shaped by billions of years of cosmic forces. Its quiet presence is a testament to the moon's long, patient history and the slow, deliberate processes that have sculpted its surface. The formation of lunar soil is a story of time, impact, and transformation. Unlike Earth, the moon lacks a thick atmosphere, oceans, or active weather to erode and reshape its surface. Instead, every micrometeorite that strikes, every solar particle that bombards it, leaves a mark. Over billions of years, these countless impacts have pulverized rocks into fine dust, mixed with shards of glass formed by the heat of collisions. The result is a soft, almost ethereal layer that cushions the lunar surface while recording the moon's history in each tiny grain. Astronauts from the Apollo missions first walked upon this soil, leaving footprints that would remain for eternity, untouched by wind or rain. Every footprint, every rover track, tells a quiet story of exploration, a gentle imprint on a world frozen in time. The regolith itself is surprisingly sharp on a microscopic level, Its grains have jagged edges formed by repeated impacts and exposure to solar radiation. While it looks soft and powdery, it is abrasive, a reminder that even in calm, silent landscapes, there is a raw, unyielding texture waiting to be discovered. The soil varies across the moon's surface. Ancient highlands are covered in fine, lighter dust, while the dark Maria, once volcanic plains, have a denser, iron-rich soil. These variations create subtle contrasts when sunlight falls across the surface at low angles, illuminating tiny ridges and casting elongated shadows. Observing these textures from orbit, the moon's surface appears both delicate and dramatic, a landscape shaped slowly by impacts, volcanic flows, and the steady work of time. Lunar soil also holds clues to the moon's interaction with the wider cosmos. Solar wind implants particles, including hydrogen and helium, into the surface, while cosmic rays bombard grains, altering their chemical composition. Micrometeorites continuously reshape the top layers, creating glassy agglutinates that capture a record of space weathering. In this quiet, seemingly still landscape, the moon silently records a diary of the solar system's history, accessible to anyone willing to study its soil with care and patience. The regolith plays another vital role. It interacts with the moon's subtle thermal and seismic activity. The fine dust insulates the surface, slowing the transfer of heat from the long lunar day to the frigid night. It cushions the slow vibrations of moonquakes, gently diffusing energy through the surface layers. Though the tremors are quiet and the environment cold, the soil responds, a soft mediator between the moon's interior and exterior. Even in silence, the soil tells stories of human presence. Every sample returned to Earth carries traces of its journey, microscopic clues to ancient impacts, volcanic history, and chemical composition. Scientists can study it for insights into the moon's formation, the early solar system, and the interactions of cosmic radiation with planetary surfaces. Each tiny grain is both ancient and modern, a bridge between celestial history and contemporary exploration. From a meditative perspective, lunar soil evokes a sense of timeless calm. Imagine standing on its surface, each footfall gently compressing the dust, leaving a temporary mark in a landscape largely untouched by the passage of time. The gray expanse stretches quietly in every direction, illuminated by soft sunlight reflecting off the jagged particles. There is stillness, continuity, and a sense of connection, not only to the moon but to the vast cosmos that shaped it. As we continue this gentle exploration of moons, lunar soil serves as a reminder that even seemingly inert surfaces carry profound histories. It absorbs impacts, records time, and cushions subtle movements. It is a silent witness to cosmic forces, an enduring testament to the slow, persistent rhythms of space. In its powdery calm, the moon offers a quiet sanctuary, a lunar lullaby for anyone willing to pause and appreciate its delicate, enduring presence. For centuries, the moon appeared to Earth as a dry, barren world, a cold desert floating silently in the night sky. Yet modern exploration has revealed that this seemingly lifeless satellite holds a subtle and remarkable secret: water. Not flowing rivers or lakes like on Earth, but pockets of ice, hidden in permanently shadowed craters near the lunar poles, quietly preserved in near-eternal darkness. These icy deposits are a delicate whisper of possibility, a reminder that even in stillness and silence, life-giving elements may exist. The first hints of lunar water came from remote sensing missions. In the late 20th and early 21st centuries, instruments aboard spacecraft detected signs of hydrogen and hydroxyl compounds embedded in surface minerals. Later, NASA's LaCrosse mission confirmed the presence of water ice by intentionally crashing a probe into a shadowed crater and analyzing the resulting plume. The findings were subtle yet profound. Ice was trapped in craters where sunlight never penetrates, preserved for billions of years in near-perfect cold. These shadowed craters, often several kilometers wide, are like natural freezers. Temperatures drop below -240 degrees Celsius, and sunlight never reaches the floor of these depressions. Any water molecules that drift into these shadows become trapped, accumulating slowly over eons. Micrometeorite impacts and solar wind interactions can deliver additional molecules, contributing to a hidden reservoir that may persist indefinitely. Unlike the open, exposed surfaces of lunar Maria or highlands, these craters create a quiet sanctuary where ice can survive in absolute stillness. The discovery of lunar water is not only scientifically fascinating but also carries practical significance for future exploration. Water is essential for life, and it can be broken down into hydrogen and oxygen, providing fuel and breathable air for astronauts. The moon, once thought to be an isolated outpost in the solar system, suddenly becomes a potential stepping stone for human presence in space. Yet even with these possibilities, the ice remains a gentle, hidden feature, quietly existing in shadows far from the warmth of the sun. Lunar ice also interacts with its surroundings in subtle ways. Micrometeorite impacts can release tiny plumes, sending water molecules into temporary vapor that may migrate across the surface or into shadowed regions. Over millions of years, this process redistributes ice across craters, creating pockets of varying density. Though imperceptible to the human eye, these slow motions underscore the dynamic balance of the moon's surface and the delicate persistence of hidden water. From a meditative perspective, the presence of ice on the moon adds an element of quiet wonder. Imagine standing at the edge of a deep polar crater, sunlight illuminating the rim while the floor remains in eternal darkness. Beneath that shadow lies pristine ice, undisturbed for billions of years, a hidden heartbeat of moisture within an otherwise dry and silent landscape. There is a sense of calm, a gentle reminder of the moon's subtle complexity and the surprises that await patient observation. Even the smallest deposits of water carry stories of cosmic history. They record interactions with comets, micrometeorites, and the solar wind. They hint at processes that shaped the early solar system and suggest that the moon's past was not entirely barren. The ice is a quiet archive, patiently preserving the signatures of countless eons of celestial events. As we drift further into our exploration of moons in this sleepy, calming narrative, lunar water offers a soothing paradox, a frozen resource hidden in shadow, quietly existing in a world that appears otherwise desolate. It reminds us that even the seemingly still and silent can harbor life-sustaining secrets. The moon, with its tranquil ice in shadowed craters, extends an invitation to pause, reflect, and imagine the delicate rhythms and hidden wonders of our closest celestial companion. When we gaze up at the moon on a calm night, we see a serene, glowing disk hanging silently in the sky. Its beauty is timeless and unchanging, yet beneath its tranquil appearance lies a subtle enigma, the moon's magnetic field. Unlike Earth, whose magnetic field shields the planet and guides compasses, the moon possesses only patches of localized magnetism, mysterious remnants of an ancient past. These magnetic anomalies are quiet, hidden features, offering clues about the moon's history and the forces that shaped it over billions of years. Scientists discovered these magnetic fields during the Apollo missions, when astronauts placed sensitive instruments on the lunar surface. Unlike Earth's global magnetosphere, the moon's magnetism is patchy, concentrated in small regions often associated with ancient crustal formations or impact basins. Some areas, such as the Reiner Gamma Formation, display swirls of magnetized rock that appear almost artistic from orbit, intricate patterns etched into the moon's surface. These features seem to defy immediate explanation, inviting curiosity and gentle reflection on the moon's dynamic past. The origin of the moon's magnetic patches is subtle yet profound. Scientists believe that billions of years ago, the moon may have had a weak magnetic field generated by a molten core, similar to Earth's dynamo effect. As the moon cooled, this global field faded, leaving behind isolated regions of remnant magnetization embedded in the crust. These areas preserve a faint memory of a time when the moon was more active internally, a slow echo of ancient energy frozen into rock. Impacts also play a role in shaping magnetic anomalies. When large meteorites strike, they can alter the magnetic properties of the surface, either enhancing or disrupting local fields. Over immense spans of time, these interactions create a delicate patchwork, a mosaic of magnetism that mirrors the moon's geological history. From orbit, the patterns look like faint brushstrokes across a pale canvas, soft yet persistent, inviting both scientific study and quiet contemplation. The moon's subtle magnetism has other implications as well. Solar wind, a constant stream of charged particles from the sun, interacts with these magnetic patches, deflecting particles in some areas while leaving others exposed. This interplay creates localized mini-magnetospheres, regions of calm where the solar wind is partially deflected, and areas where the surface is gently bombarded. Even in silence, energy moves, revealing the moon's quiet responsiveness to forces from both within and beyond. From a meditative perspective, these magnetic mysteries offer a gentle sense of connection. Invisible yet present, the moon's magnetism affects dust particles, solar winds, and even instruments brought by humans. It is a quiet reminder that unseen forces shape the environment in subtle ways, much like the gentle influence of gravity or the soft pull of tides. Observing these anomalies encourages patience and attention, a recognition that not all of the moon's wonders are immediately visible to the eye. Future exploration may reveal even more about these quiet magnetic regions. Understanding them is crucial for designing lunar habitats, shielding astronauts from solar radiation, and planning long-term missions. Each patch of magnetism becomes both a scientific resource and a testament to the moon's hidden complexity, a calm reminder that even seemingly simple landscapes can harbor secrets beneath the surface. As we continue drifting through sleepy science facts about moons, the magnetic mysteries of the moon provide a soothing reflection. Beneath its serene appearance, a subtle energy persists, tracing a history billions of years old. These faint forces are gentle, steady, and enduring, much like the moon itself, quietly orbiting Earth and guiding our imagination through the calm rhythms of space. In their hidden presence lies the beauty of subtle motion, an invisible lullaby echoing across the lunar surface and into the quiet night sky. Every day, as oceans rise and fall, the moon performs a gentle, invisible dance with our planet. Its gravitational pull tugs at Earth's waters, creating tides that ebb and flow with a rhythmic consistency. This relationship is subtle, calming, and essential, a quiet reminder of the moon's ongoing influence on Earth long after its formation billions of years ago. The tides, moving in and out, reflect a cosmic connection between two celestial bodies, a lullaby of water and gravity playing across our planet's surface. The mechanics behind tides are simple yet elegant. The moon's gravity pulls more strongly on the side of Earth closest to it, drawing water outward and forming a bulge. On the opposite side, inertia creates a second bulge, resulting in 2 high tides and 2 low tides each day in most coastal areas. The sun also contributes to this motion, amplifying or diminishing tides depending on its alignment with the moon, producing spring and neap tides in a steady rhythm that has persisted for millennia. Tides are more than scientific phenomena, they are a source of calm and reflection. Observing the gentle rise and fall of the sea can evoke a meditative sense, mirroring the moon's own steady orbit. Fishermen, sailors, and coastal communities have long attuned their lives to these rhythms, integrating the moon's influence into daily life in a manner that is both practical and deeply poetic. In this way, the moon connects human experience to cosmic patterns, fostering a sense of harmony between Earth and its companion in the sky. The moon's influence extends beyond ocean waters. Its gravitational pull also affects Earth's crust, creating small land tides that subtly flex the solid ground. Though imperceptible to most people, these movements reflect the moon's persistent presence, a quiet reminder that celestial forces operate continuously, even in ways we cannot always perceive. The subtle stretching of Earth's crust, combined with oceanic tides, demonstrates the moon's role as a steady guide, shaping environments with patient, persistent energy. Over millions of years, the moon has slowed Earth's rotation. Tidal friction gradually transfers rotational energy from our planet to the moon's orbit, causing the moon to drift away at a rate of about 3.8 centimeters per year. This slow, deliberate motion affects the length of Earth's days, a gentle, ongoing transformation that highlights the interconnectedness of planetary systems. Even the smallest movements have long-term consequences, emphasizing the calm, persistent influence of the moon. From a meditative perspective, tides are soothing reflections of the moon's gentle power. Watching waves roll onto a shore, rising and falling with predictable rhythm, creates a sense of continuity and balance. The moon's orbit may seem distant, abstract, and unchangeable, yet its influence manifests in tangible, comforting patterns that connect humans to the cosmos in quiet, unassuming ways. Tides also provide subtle ecological rhythms. Intertidal zones rely on the ebb and flow of water, shaping habitats for countless species. These natural cycles, driven by the moon's steady pull, support life and maintain equilibrium across ecosystems. Even in their quiet operation, tides are a reminder that the moon's presence is both nurturing and enduring, a gentle influence that fosters stability and calm. As we continue our sleepy exploration of moons, Earth's tides remind us of a connection that is immediate, gentle, and continuous. The moon's orbit shapes rhythms that touch the senses, from the subtle swaying of waves to the unseen flexing of the land. Its presence is a quiet anchor, guiding our planet through cycles of light, shadow, and gravitational balance. In the soft rise and fall of the seas, the moon whispers its cosmic lullaby, a calming rhythm echoing across oceans and into the serene night sky. As we reach the final chapter of our journey through sleepy science facts about moons, it is fitting to reflect on the moon itself, the ever-present companion that has quietly circled Earth for billions of years. From its pale glow in the night sky to its gentle influence on tides, its phases and eclipses, the moon is more than a celestial body. It is a silent guardian, shaping life and inspiring imagination in ways both subtle and profound. Its presence is constant, reliable, and calming, a cosmic anchor in an ever-changing universe. The moon's formation tells a story of dramatic beginnings. Scientists believe that a Mars-sized object collided with Earth long ago, ejecting debris into orbit. This debris gradually coalesced into the moon we see today, a product of violence that evolved into stability. Over billions of years, the moon cooled, developed its surface of craters and maria, and settled into a synchronized orbit with Earth. Its very existence reminds us that even in chaos, patterns of order and balance can emerge, a gentle lesson in patience and cosmic rhythm. Through its orbit, the moon shapes Earth in profound ways. Its gravitational pull stabilizes Earth's axial tilt, which moderates seasons and contributes to a stable climate. Without the moon, our planet might wobble unpredictably, leading to extreme shifts in temperature and sunlight. Its presence allows life to flourish in a steady, measured environment, an unseen guardian silently preserving equilibrium. The moon also continues to inspire curiosity, art, and reflection. Its phases offer a natural clock, its eclipses a display of celestial precision, and its quiet surface invites exploration. Through telescopes, orbiters, and human footsteps, we have learned about its rocks, soil, ice, and subtle magnetic fields. Yet, despite all knowledge gained, the moon retains a sense of mystery, a calm presence that evokes wonder rather than complete understanding. This balance between familiarity and enigma contributes to its soothing effect, encouraging contemplation and a gentle slowing of thought. Even beyond science, the moon shapes human perception of time and beauty. Artists have captured its glow, poets have described its calm light, and countless people have looked up to find solace in its soft illumination. It acts as a nightly companion, a steady presence that encourages reflection, meditation, and a sense of continuity. Its cycles, waxing, waning, eclipsing, casting shadows, mirror the gentle flow of life itself, a comforting reminder that change can be predictable, rhythmic, and beautiful. The moon's influence extends far into the solar system. Its subtle gravitational effect has guided orbital dynamics, influenced tidal heating in other moons, and helped humanity understand the mechanics of celestial motion. Each ripple of its presence, though imperceptible to casual observation, demonstrates the quiet power of steady forces acting over immense spans of time. It is a reminder that strength can be gentle and impact can be profound without noise or chaos. As we conclude our exploration, the moon stands as a symbol of calm endurance. Its craters and valleys tell stories of billions of years of cosmic events. Its ice and soil preserve history. Its phases and eclipses offer nightly performances of light and shadow. and its gravitational embrace shapes our planet in ways both tangible and unseen. In all of this, the moon teaches a simple yet powerful lesson, that the universe moves in quiet rhythms, and that even in silence, there is profound influence, gentle guidance, and timeless beauty. Drifting through space, orbiting Earth with steady devotion, the moon remains a silent guardian. It invites us to pause, breathe, and observe the world and sky around us. Its presence soothes, its motion reassures, and its quiet mysteries inspire. As you look up tonight, the moon casts its soft light across the world, a cosmic lullaby, a calming sentinel, and the final note in our gentle journey through the science of moons.